Okay, so with that being said, so today we're going to talk about area and volumes, but we're going to talk about area first, and we're going to talk about volume. The homework I only did assign just the volumes, because technically, if you understand volume, then the area you can actually figure out. So, but we're going to go back give homework on the volume areas as well. So first thing first, you have to understand how to take a derivative e to the x, integration e to the x. Those things are needed to be understand. So the test is sometime next week. So you got to prepare of area, volumes, and even integration of e to the x and derivative e to the x. Okay, so those are things that you should concern about. So let's talk about area between the curve. The area between the curve is gonna have this. So and Paige, if you have a question, just shout. And if you cannot shout, you can send it to text. So we're gonna do is area between the curve. Most of you guys put your phone away, or I'm gonna assign somebody to throw people's phone away. Yeah, throw it out the window. If you're not focusing, because today's stuff is very challenging. It's very challenging because we're gonna talk about the whole chapter as opposed to one section. So we talked about whole chapter. So start by asking something that's relatively easy. First of all, we're gonna create a situation. So we're gonna talk about area between the curve first. So area between the curve. And what we're gonna do is we're gonna create some type of situation. We're gonna create the situation here, and we're gonna draw something like this, and we're gonna have something like this. This is f of x, and we're gonna something like this is gonna be g of x, and we're gonna have a and b. So let's just say we have a here, and we have a b here. And we're gonna use black here, a and b. And let's just say if I want to find this area that is right here, how do I find this area? Like, how do I find this area?
Integral between a and b of f of x minus the integral between a and b of g of x.
Okay, people are very, very conceptually understanding what's going on. You can grasp it very, very easily. So I'm gonna give you a second that we're gonna give you a more challenging situation that you have the right idea. So what we're gonna do is we're gonna take this and we're gonna copy and we're gonna paste right here. And we're gonna write it again. And we're gonna copy and paste in situation again.
So
okay, so no, not lost yet. It's very easy. So
holy.
okay, so that's that. So what happened is, first thing is, if I do integration, just like what Andrew says, if I do integration of f of x between a to b, I will get this red shaded region like here, and I will get from here, I will get right here. Not only that, we're gonna go all the way down, and we're gonna get that right here, this region. And what happened is I'm gonna take away the integration of g of x, which is gonna be here. And we're gonna say, if I take area under the curve, then it's gonna be that blue region. Now, if I take the red, right, minus the blue, it should be the black. Does that make sense?
I'm with you so far.
Okay, so red minus blue equal to that. So how do I get red? Red is going to be integration of a to b of f of x. And good job, dx. And then I'm going to do a integration of g of x dx. And then we're going to take a minus sign. And this is because area between two curve.
Do you have to have two functions to find area between the curves?
That's a great question. Usually is always two functions. I mean, can I ask you three functions? That's just gonna be very confusing for students, so I will not do that.
Piecewise.
So, no. Area between two curves is gonna be like this. So basically, in general sum, it's always this. Is area between the curve is also equal to integration of top function minus the bottom function. And between A to B, and that's an easy way to think about it. Top function minus the bottom functions, and that's an easy way to think about approach it. Okay. Anthony, are you paying attention to here, or are you paying attention to your phone? Oh, what are you on?
You little jet on your phone, man.
Where?
You're just picking his fingers.
He was picking his nose. Digging for gold.
Okay, so top minus bottom. And so sometimes we're gonna give you that is the region is assigned to you. And sometimes we're gonna give you region is not assigned to you. You have to figure out between the curve. So there are two situations can happen in the situations. Sometimes if I give you a bounded area. So sometimes if I give bounded area. And what I mean by bounded is because I have a from the x restriction from two values. If I have two bounded area, then that's pretty easy. That's just integration, right? Integration between A to B of top minus bottom. And I'll rewrite this again because that's very important. Now, if it's bounded by the graph, so for example, if you have two functions that they have intersection, what I mean by that is like this. If instead of asking A to B here, if I were to ask you between here to this. Now, what you're going to do is that's not bounded between A and B. It's bounded by the graph. It's bounded by graph. You have to find what first? You have to find intersection. So if the area between the curve is bounded by the intersections. It's bounded by intersections. CURVE is bounded by intersection. Bounded by intersections. Sorry. You have to find intersection first. Find intersection first. Find intersection first. Once you find intersection, then you can say, oh, say from this A to this B. Okay, so I'm gonna give you first situation is I give you the two boundaries. The second situation, I'll give you find the boundary. So how do you find the intersection? You just set f of x equal to g of x, set two equations equal to each other, and move it to the other side. Do not divide it by x on both sides by any way. We're gonna talk about that, why that's a bad. And then you can do is a factor and solve. Okay, factor and solve. So this is a second situation. So let's talk about first situation first. You have to be able to graph the functions though. So if I graph the function, let's just say, if I give you a function, let's say this, y is equal to x squared plus 2. We're going to call this f of x. And we're going to write down red. Is f of x equal to that? Equal to x squared plus 2. And I'm going to give you another function says g of x. We're going to use blue. So g of x is equal to negative x. So first of all, you got to be able to graph this on your paper. So I want you to practice graph this. And also we're going to give you two different bounds here. We're going to give a boundary is we're going to use black to show you that x equal to 0 and x equal to 1. So I want you to graph this, and if you're good, you can find integral. If you're good, you can find the area between the curve. But I'll give you like a 30-second head start so you can graph the function first. At a minimum, students have to be able to graph a simple function like this.
Wait, what did he? Wait, what are the x's are bounds? 0 and 1?
Yeah, because the x equal to 0, x equal to 1 is the vertical line. Okay, we're gonna show you where the vertical line occur, but I'm gonna go ahead and graph the functions. But definitely graph it first. You gotta make sure you can graph this function, because sometimes it's gonna be your algebra skill that's gonna determine your fate in your calculus grade. This is a 1, 2. Every 2 space I'm gonna use this 1, 1, 2, 3, 4, 5, 4.
Oh, right.
Wait, you want to find you want me to find the area between the curves?
I want you to graph it first.
Yeah, I already graphed it.
Okay. The graph looks good?
Yeah.
Okay. And I want you to find the area between the curve. Yes.
From 0 to 1.
Well, you have to graph 0 and 1 first. So that way you know what I'm talking about.
You said from 0 to 1.
Oh no, I did the wrong.
Oh wow, that's
super
hard. I'm really so slow.
Paige, you can see stuff on my board, right?
What?
Yes, I can see.
Mr. E is my literal dog.
So the next grade
Not comparing Mr. E to a dog.
Well,
Oh!
it's from 0 to 1. So
So the graph of an x squared plus 2, you should understand how to graph that to even very, very precisely. But if you don't, it's not end of the world. But I should be able to graph precisely because x squared plus 2, that's just a parabola moving up or right. Up how many units?
2.
2 units. So this normal parabola will look like this. It will 0, 1, 1, and then 2 around 4 right here. So it's gonna be like this. This is normal parabola, but it's everything gonna shift up 1. So this is gonna be 1, 1 here. So there's gonna be 1 here, and 2 is gonna shift up 4. So it's roughly right here. But again, I don't need that. I just needed the first part. So this part is gonna be right here, and like this. And how about a blue graph? Negative x. What does the negative x graph look like? Yes. Going down. Good. What kind of slope is that? Straight negative 1. Good. And then I'm going to graph the 2 black line. I'd color code this for you so that you can see. And then this is the region I care. This is called boundary region. See this boundary region? That this is the region I care. I don't care about this area. I don't care about this area. I don't care about this area. I don't care about this area only. I don't care about this area. I only care about this area right here. It's not a trapezoid because the other side is a curve. Okay, so now what you're gonna do is top minus bottom. What is the top in here? X squared plus 2. And the bottom function is gonna be what? Negative x, and then this is a minus, and then dx, and that's it. That's the way to set up. Is it hard?
No,
No, it's not.
it's quite.
It's gonna get too hard pretty soon.
No.
So x squared
It's hard
plus 2 plus x, because the minus negative, that's become like this. And if you work it out, it's going to be x3 over 3 plus 2x over 2 plus x squared. No, 2x. Sorry, I can't do that. Plus 2x plus x squared over 2 between 1 to 0. And it's going to be 1/3 plus 2 plus 1/2. That's equal to 17 over 6.
Ooh, 7? Or am I getting that?
No, I got that. I got 17 over 6.
Whoa. That really so soft.
You literally just take the
Oh, I
integral
know.
and plug it in.
What did I do? Oh, I did minus on the 2x for some reason.
Wait.
Because you're going to minus 0, minus 0, minus 0.
No, I
didn't
just
write
looked
it.
at it wrong. I read the question wrong.
Wait, let's forget, where did the x's go when you went from the third line to the fourth line?
I plug in 1,
Oh, you
and then I plug in 0 to subtract each other. But I didn't write down the 0.
Nothing.
So technically it's like this, if I really want to do it.
Wow. Here we go.
Yeah. Okay.
Nice.
Okay, so the next question, you're gonna have to find your own boundary now, because I don't give you that 2 vertical line to bound it. Okay, so you're gonna be like, let's see if I can do this. You see if you can do this. And the graph, you have to sketch as much graph as you can. But since you're gonna find your own boundary, you don't really care about if you can graph the intersection. But you can do is figure out what is it. So I'm gonna let you have a head start. I will have 1 minute, 2 minutes head start here. So that's gonna be 2 minus x squared. And we're gonna say g of x. Now, do I always g of x on the top or f of x on the top? Not necessary. Just in this order, I just give you the question this way. So the first function is going to be 2 minus x squared. I want you to graph it though. I want you to find the intersection. I want you to solve. See, if you're really strong, you can go all the way down without me helping you. But if you are somewhat like not sure if you accomplish it, graph it first. Find the intersection. That's the only thing I'm asking for. I'm not asking you to do integrations. I'm going to show you a shortcut on the integration too. I'm going to show you the shortcut, and you got to pay attention to the shortcut. You might have to write down that shortcut part.
From what to what?
They didn't tell you.
Just write the equation.
Oh.
Find your bound.
And that's a lot of work, Mr. Ye.
No, listen,
He's being silly guy.
he's being a little shit.
Most men live quiet lives of desperation.
That's so wise.
Well, I guess.
Alright, I found the bound.
Yeah, I know.
Will smells like shark.
You write the book.
Yeah, he probably did.
You know exactly what I mean.
We want to talk about the area right now, so we haven't get into a heavy part. But yeah, the first part you can listen to the go back to watch the first part. First part's not too bad. But if you understand this question, you're doing good.
What is you?
U is equal to submissive.
Okay, so what we're gonna start is graph the 2 minus x squared. So 2 minus x squared is 2 to the left. I don't know about that. I don't think about that. No,
What?
it's not 2
Two
to
up.
the left.
It's 2 up, yeah.
Okay, so you gotta be careful. It's not x parentheses something. It's x parentheses something is moving left and right. But it's just x squared in general. It's just that negative x squared. What does x squared graph look like?
Upside down.
Okay, so then negative x squared is gonna be upside down parabola. But the 2, what's gonna 2 gonna do?
It's
It's
gonna
gonna
move
move
it
it
up
two to the left.
2 when it's at 0.
Not 2 to the left.
Y
Dang it.
equals 2 when x equals 0.
So yeah, so it's gonna be vertex is gonna be up curved right here. And then if you can draw a beautiful graph like me, then that's great. But if you cannot, it's not end of the world
How beautiful.
because yeah.
Stop drawing Among Us is on my graph, Josh.
Serious, Josh?
From -2 to 1.
What?
I'm only sitting next to the projecting. I actually watch myself.
Okay, do you guys see this graph I drew?
I did.
And also g of x, I'm gonna have this. Now again, none of you guys can draw as beautiful as this. Not like saying anything else, but it just
You have an iPad, Mr. Ye.
yeah. And I also have a way to draw straight lines. And also there was a graphing paper, so that helps a lot. But the problem is, what if you don't have graphing paper? And so you really need to rely on algebra skills, right? Algebra skill just say, hey, let's set the two equations equal to each other. So two, we're gonna use red. It will be 2 minus x squared is equal to x squared, and we're gonna set them equal to each other. And then when we say as x, sorry, we're gonna set them equal to each other, and we solve for it. Always I solve, I make sure leading coefficient is positive. Are you just stretching?
Well, no, I have a question.
Yeah.
So like, I always gonna have graph paper. It's like on the AP exam, right? Do they give you scratch paper, or you only allowed to use paper?
You have some paper to scratch.
graph paper, or no?
No graphing paper. So that's the thing. So that's the thing is you can't really rely on your graphing. You need to rely on your algebra skill in this case. So then I'm gonna move the leading coefficient to the right because I don't like the negative sign. That's just not my type of t. So plus x and the minus 2 is equal to 0.
Oh my goodness, you can solve by factoring.
Oh my goodness. Algebra 1, right? So it's gonna be x plus 2 and x minus 1. And x plus 2 equal to 0. X equal to negative 2. X minus 1 equal to 0. X equal to 1. I cannot talk over you guys. So it's gonna be this. So the way that I'm calculating the area is gonna be adding this small lines, and this is vertical line, so that's a dx. So those are dx's. So I'm gonna adding from negative 2 to all the way 1. So now I have some natural restriction now. So I can do integration. The top graph is the f of x. It's always top minus bottom. So therefore, it's going to be f of x minus g of x, right? G of x is going to be here. And now we're going to subtract. It's always f of x minus g of x? No, just in this case, that the f of x is on the top. So I'm going to write down f of x here. So we're going to say between what value to what value? Negative 2 to 1. And so 2 minus x squared minus x dx. Now, I'm going to show you the shortcut. Pay attention. Shortcut. You will want to pay attention to the shortcut. Shortcut is actually knowing how to do fraction and do it more efficient way, especially integral like this. I'm going to show you how I do it. So if I do it, I'm going to integrate this. So it'll be 2x minus x cubed over 3 minus x squared over 2. And between 1 and negative 2. Unlike last question, 1 the boundary is 0. So you're going to plug in 0, 0, 0. Life is easy. Move on. This is not that easy. This is kind of like, I have different here. So I have to really figure out how to do subtractions of fractions. But now I'm going to plug in. I'm going to show you 2 minus 1/3 minus 1 square over 2. So it's half. And then minus by another value, which is negative 2. Negative 2 times 2 is negative 4. Negative 2 times 3 is negative 8. So it'll be positive 8 over 3. And this one's going to be plus minus 2. Okay. So now I'm going to show you the shortcut. Here's the shortcut. It's understand common denominator. So what I will do is I will take care of this and this one. Why that one and that one? If you pay attention, they have some denominator. I can subtract without converting. So instead of adding those 3, this is going to be all the way to denominator 6. Then you're going to have to do a lot of arithmetic. I don't really want to do that. I'll just keep you this. I take this 2 and subtract negative there. So that's going to give me 6. Does that make sense? And I'm going to go to the next one here. What is negative 1 minus 8 over 3? Negative 1 over 3 minus 8 over 3. Which is equal to? It's so easy if you did it in more efficient way. Now, what's 1/2 minus negative 2? It's just going to be plus 3 over 2. So that's equal to 3 plus 3 over 2. That's end up to be 9 over 2. And that's the final answer.
Oh, where is this?
What'd you say?
That works with every case, because no matter what.
Yeah, no matter what, both things. So some people say it's that with all the case. Most of the case, they're going to have same denominator. So you can just work on the same denominator, right? And then combine those two, and then just work on those two to get it down. it's more efficient than try to combine the first fraction of first thing and combine the second one, and you have to add and subtract both. It takes longer to do, and that's what I'm saying. Everything, there's always shorter way to do something. You want to think efficient. You not want to think about, well, what's the longest way to do something. That's idiotic, right? So we want to make a very efficient way to do it. Now, here's the thing. Can they have more than two intersections?
Yeah.
Well, it really depends on the graph, right?
If it's a sine, let's say if it's a sine graph, you could have a bunch of intersections.
Exactly.
Sine of y.
But we're not going to deal with sine graph. We're going to stick with algebra here. So, but the problem with that is, let's look at this questions here. Y is equal to x to the cube and y equal to x. Now, nobody, you guys don't know how to do graph x cube. X cube kind of look like, for me, it's kind of like a waterfall. It's like this.
Yeah, it's like
It's like proceeds to cry.
Okay, so I'm gonna draw a longer scale on it. One, 2, 3, 4. Okay, so basically it's gonna have something like this. And the problem is this one is gonna be a lot. Do you guys remember this now?
yeah.
And the y equal to x is gonna have like something like this, right? So it turns out I know how to graph. I know how to graph this very well, and like I say, I can see 3 intersections. Will, Lucas, sit up here because Will doesn't have. If I put 2,
Me and Will were just being gay, sir. No problem.
We were so close to kissing, you ruined the vibe.
I'm sorry. I'm a good third wheel though.
That was a good stretch.
I
Now.
know you have hepatitis, but yeah.
I don't.
What?
Let's-
Anyway, oh my god.
Okay, so this part, then you say, okay, well, I got this, because there are 2 region bounded now. So, but the problem is, if you look on the right side of the region and left side of the region, the graph, on the top is kind of switch. Do you see that switch happen? So you had to pay attention to that switch as well. But first thing first, let's find intersections. Now, I went over the same question yesterday in my algebra group. I have a lot of kids are taking algebra with me on the side. And we're going over this question. And we're trying to explain this question to you guys. Is this question, it happened in my high school when I taking calculus. The first test I failed. I got negative 20 points taken away from don't know how to solve x cubed equal to x. So what I did is, I'm going to show you what I did. I'll divide by both sides by x.
Oh my.
And I got x squared equal to 1. And I went on to make another mistake. I said x equal to 1. And then,
Plus or minus?
and yeah, I even forgot plus minus. So that there was an x equal to 1 here. And then my teacher marked out 20 points. I'm like, man, I got at least one part of the answer correctly. Like kind of Miriam trying to argue in points like that. And she's like, and this old lady says, no, that's the wrong answer. And I say, why? Is it because? And she says, you don't know math. And then and she following say this. She says, you don't belong to my class.
She's racist. And then you beat her ass.
No. But the thing is, she's absolutely right. She's 100% right. She's more right than ever. She told me everything I need to know right now to teach you. Actually, I didn't learn this in college. She told me everything right here in this lesson. She's like, you're not good enough. So, which is great because that's the best thing happened to me because I was like, I'm Asian. I must be smart in math. And I went there, I take a test. I got a 58. Then it just proved to me I'm not so smart. So cubed minus x, you're supposed to move set the equation equal to 0. You're supposed to factor out GCF. And you're supposed to solve like this. And actually, according to her question on this one, she says, find the solution 3 different ways. She did not just only accept this answer. This is only first part of the answer. X equal to 0, x equal to -1, x equal to 1. So what did she say how to solve 3 different ways? The 3 different ways you had to graph this function. Or you had to graph this function, x cubed minus x. Now graphing x cubed minus x is kind of hard. It looks like something like this. And there's 3 x-intercepts. So she says you have to solve 3 different ways to do the same answer. And she assigned this question like 30 points. And she's like, I don't even supposed to give you 10 points. But anyway, that was a very, very important lesson for me. So I'm trying to teach you that that's happening. So how do I set up the integral if I want to set up correctly? If I want to do a 2 integral, and if you're really good, you can figure out a way to do 1 integral because they are symmetric.
Yeah. You can do it from negative.
-1 to 1.
Yeah, wait.
So let's just set up 2 integral first, and then set up 1 integral, and see if we match up with each other. Oh, also another thing that the answer is not 0, so answer just totally screw up.
Oh no! Is it a bit above it?
No. So I'm going to talk about if some area, let's go back to talk about this situation.
Integral.
Let's just talk about this. If some graph is underneath like this, right? And I'm trying to find this region right here. And then this area is still positive, by the way. The integral, if I find the area between the curve, it's always positive because top minus bottom. It's, for example, if you have -1 minus -5, that's still positive 4. It's still positive, even though it's below x-axis. So in below x-axis, the area between the curve is still positive. We're not saying integral. We are integral is top minus bottom. So that's what results still positive. Does that make sense?
So is the is it 2 times the integral to 0 to 1?
Huh?
Is it 2 times the integral from 0 to 1?
Yep.
Well, that's a way to think about it, yes. So in this case, I can set up, if I'm going to set up 2 integrals, I'm going to go from -1 to 0. What's the top part of the graph?
Top part?
For which
For -1 to 0, x cubed minus x dx plus integration of 0 to 1 x minus x cubed. And if you solve for this, it's going to be equivalent to this. 0 to 1, 2 times x minus x cubed dx. And that's a faster way to approach it because in this particular case, not all case, in this particular case, it's symmetrical. Not all cases are symmetrical, so you had to pay attention to symmetrical situations.
Would it have made a difference if you made x cubed negative or x negative?
Yes.
Yeah, that would be different.
How do I tell which one
Is
is
it
negative?
equal to 1/2?
Huh?
Don't ever do it that way, Rika. You never need to do it.
I did it while you were.
But how do I
So
know which
2, and this one is going to be integration of x is going to be x squared over 2 minus x4 over 4 between 1 to 0. So it's going to be 2 times 1/2 minus 1/4. So equal to 2 times 1/4 is equal to 1/2. Now you could get this is also equal to 1/4, and this is also equal to 1/4. Okay, any question before I move on? Marian, do you have questions? Maria, Jinju? Good. Okay, Paige has a question. Hold on, let me answer Paige first. Paige?
So why do you switch it from like x cubed minus x to x minus x cubed?
Okay, that's a good question. She said, why do I switch? Now look at this part, look at this region, right? If I'm going from -1 to 0, so that means I'm going from this region to this region. This is the top part of the graph, which is x cubed. And this part is the bottom part of the cube. Now, if I go to here, the x is going to be on the top, x cubed is on the bottom. Did I answer your question?
Yeah, thank you.
No problem.
Well, can you also just do 2 times 0 to negative 1 of x to the third minus x.
Yeah, but that's one's gonna give you a negative value because if okay, negative 1 to 0. Did you say negative 1 to 0 or 0 to negative 1? 0 to 1.
0, no,
It really depends on how you say it.
it's 0 on top, negative 1 on bottom.
Yeah, so negative 1 to 0. Yeah, you can do that. It'll be x cubed minus x. Yeah,
Yeah.
you-
I just did it how, like, I did it like while you were talking. I just did it how you had it written up. I didn't do the 2 times 1 to 0.
yeah, that's fine. That's fine. Okay, so the next thing is
Mr.
Mr.
Can you
Yang,
explain the 2 thing again? I still don't really understand it. Why you put 2 there?
okay, so why did I put 2 here? So 2 is just because this region, even my graph is very crappy. So this 2 region is supposed to be symmetrical. So I can just do one part here and multiply by 2. So like if you have 2 leaves that is exactly identical, can I just find the area of 1 leaves and then you multiply it by 2? Yes, Paige.
like, how can you multiply it by 2 if it's like because it's x cubed minus x, but then the other one is flipped. So how can you just multiply that by 2?
Because it's symmetrical.
Because this region is gonna give you a probably 1/4, right? So can I just double it? Because they are symmetric from one side to the other side.
But wouldn't one be negative?
No, they won't be negative because the other side you had to switch the boundary just like what we did before. So the other part is x cubed is on the top, x is on the bottom. If I switch, it's gonna give you a negative. But so you just that way. So let's just say if I find if I give you a black heart, like black heart and a white heart, and I says, hey, can you find the area of 2 hearts? But it doesn't matter they are black or white, they are all positive areas.
Bigger than black.
So if they are even sizes, of course. I don't know if that answers your question.
Yeah, okay, thank you.
All right, no problem. Okay, so that's that. The next challenging is not a bad. The next challenging is gonna be like this. The next challenging is the question is gonna be kind of weird though. The way the question is worded is gonna be kind of weird. Is you have to look at in terms of this is the things I have to teach you today. Today you have 2 perspectives. One perspective is the dx perspective. Now there's another perspective called dy, and you're like, whoa, dy. No, but it's like same idea. It's like you just have to solve for a certain situation. So I'm gonna give you a situation here. We're gonna say x let's just say I say 3 minus x. No, we haven't started yet.
Oh my god.
Okay, 3 minus x equal to y squared. And we got x equal to y equal to x minus 1.
I mean, I think that doesn't. Like,
Take a derivative.
Wait, what are we doing?
So we want to find the area between 2 regions.
Oh, I was like,
And there's the 2 equations here. Now, here's the thing. In this situation, if you solve for y, you can get some weird situation, which is y equal to square root 3 minus x. But if you y equal to 3 minus square root of x, you're going to get half parabola. But this y squared is actually full parabola. Okay, it's actually full parabola. So those are things that you have to think about. So in order to stick with the full parabola, then at this situation, I will solve for x. Solve for x. How do I solve for x? If I solve for x here, I'm going to get x by itself. And every function is going to be in terms of y. Does that make sense?
Yeah.
So if I change this, can I just say, hey, that's equal to, if I solve for x, it's just x move over there. So x equal to 3 minus y squared. And x equal to y plus 1. Now this one's going to be f of y is equal to 3 minus y squared, not f of x. And this is g of y is equal to y plus 1. And don't worry about that function. That function looks really scary, f of y. You've never seen f of y before. You only see f of x all your life. This is the first time you see f of y. Oh my god, the life's over. No, it's not over. It's the same idea, just in the y perspective. So y becomes the input. Now here's the thing. Here's the next challenge. How do I graph 3 minus y squared? Okay, so this is the x squared. Right?
Oh,
This
it's gonna be this. You know what I'm saying?
is
In the positive x direction.
YMCA. No. Yeah, so y, yeah, it's actually YMCA.
It'll look like this.
Alright. That's gonna be like this, right? So it's going toward the right, but the problem is this is negative y squared. So I'm gonna show you how to work. If I have y equal to x squared is equal to look like this, y equal to x squared, and that's fine. So x equal to y squared is look like this. Okay, but what if it's negative y squared? Because that one is negative y squared. So what does that do?
It's quite literally the YMCA.
Quite literally, yeah. And then, so the things about it is, not only that, you have to think about, well, it's gonna be plus 3. Wait, plus 3. Do I go up 3?
Go right.
Yeah. Go up.
No.
Go down.
Go up.
The y plus
Ask if it's plus 3, right? It would be up.
3 minus y squared.
Go down 3. Go to the right 3. Wait, no, it's negative. It's negative. Sorry, it's going up right. It's the same function as the right.
Oh, it's going right through because it's an inversion, so the y's and x switch. So it's going, yeah, it's literally going right through.
Okay, so let's see who's right. Plus 3.
Yeah.
Think on it.
Does that make sense? Does that make sense? Is you moving right 3 because you're looking in terms of y perspective? The more positive it goes, it's going right.
It's the same thing as an inverse function.
Yeah, they are actually technically. Good job. So this one's gonna be y squared. So this is my vertex, and it's gonna go this way. The problem is you graph y equal to square root of 3 minus x. It's gonna be only in half the curve, which is bad. You want to see the whole curve. So that's not a good way to think about it. So he's gonna go into here. You're gonna graph it. You're gonna go like this, and going like this. And this point is going to come back this, and come back this. Okay. And then what about x equal to y plus 1? Well, we know what's x equal to y. That's just a diagonal 45-degree line, right? Now, is that line going to move which direction?
Yes.
So if I just have x equal to y, it's going to be this. Is that going to move the graph to the right or left or up?
right.
To right.
Yay.
So in terms of this perspective, they're always the same. So, and now the way to think about you calculate the area, the way you calculate the area is this perspective now. So that's going to be dy.
Whoa, wait.
Okay, so not only that,
Wait, real quick, is there a function on our
Why?
Can our calculators do this sort of thing?
TI inspired mine, but TI-84 no.
Wouldn't that be
I'm on a
good?
thing to check real quick, just out of curiosity.
But it does mill scan. So I prefer use this.
Why like that?
Now, can I set those two equations equal to each other?
Yes.
And then can I say it's y squared plus y? Right? Can I say y squared plus y? And wait, y squared. Wait, I did it wrong. Yeah, y squared plus y minus 2 is equal to 0. So that's going to give you y plus 2. It's the same situation as 2 cases ago. And that's equal to y equal to -2 and the y equal to 1. So if you think about it, this unit here is at -2, which is kind of makes sense. And this unit here is 1. So let me show you here. This one's 1, this one's a -2. So it went from -2 to 1. And the way you accumulate area from negative to positive, you keep on adding up. You're adding each individual slice and you add up to there.
Wait, can you explain the y plus 1 graph to me real quick? Because my brain is like tripping out.
Okay, so think about x equal to y. We know how to graph y equal to x, right?
Yep.
But instead of +1, but we +1 to the y perspective, so it's going to be +1. So it's going to be going from here to here.
But
Or you can solve, if you really have issue, understand how y works, then you can move the 1 to the other side, equal to y equal to x minus 1. Then the y-intercept at -1 has positive slope of 1. So that's another way to think about it.
If you rotate both of the graphs, then you can still get the same answer for the shaded region. I mean, that would be pretty convoluted though.
Yeah, well, technically you can do that, but the thing, the ideas I'm trying to teach you, there's a dy. So remember that last question that last formula I gave it to you is top minus bottom, right? In this one is what? Is right minus left. And I'm going to show you in a second. It was between A to B, and this is dy. Right minus left in terms of dy. Why is that? Now, if you turn your head 90 degrees to the right, like this, you can see why it's right minus left now.
Yeah.
But 2 days ago, I asked Paige to turn to the right. Not Paige, not Paige, but Katie. Katie turned to the right. She goes like this. I'm like, no, wrong side, Paige. Yeah, so sometimes you don't get confused right and left. But if you turn your head 90 degrees to the right, you see the right graph is on the top.
I don't know my left or right, Misty. Yeah, I gotta be honest.
I know. You're not the only one.
wait,
You're not only one.
Move your head. You said move your head to the
To the right, sideways. You see that right is on the top, right?
well, then the graph is negative.
Or you can turn the paper, yeah, but I don't want your corrections.
Or just memorize the formula.
Oh yeah, just memorize the formula.
If you can memorize the quadratic formula, then you can memorize.
Yeah, right minus left. How hard could that be, right? Top minus bottom, right minus left.
Just be positive minus negative. Take the most positive one and subtract the most negative one.
So if I do integration of top, in this case the top is 3 minus y squared, which is right, by the way, minus y plus 1 dy, and that's between from -2 to 1. Why is -2 to 1 is not 1 to 2? Is because you're going from this to this. The way you calculate, you're going to calculate this, and you're going to stop at 1, and you start at -2. And that's the way to think about it. And the answer on this one, it happened to be very symmetrical. If you look at this region, right? And you look at this region, right? They're identical pretty much. They just shifted a little bit left and right, and they shifted a little bit up and down. They end up to be the same answer if you work it out. I'm not worried about you working out. I'm more worried you setting up an equation correctly. If you're setting up an equation correctly, then you're going to get a right answer. So you end up to get 9/2. Same region as the other one. So now we finish areas. So now we're going to relax a little bit. We're going to actually give you a very, very new perspective, relaxing. Now, my favorite thing is go watch YouTube. And one thing that's most relaxing is actually watching the woodwork. I don't know if you see woodwork.
Yeah.
Yes.
No.
I love it.
No,
You seem like
oh, you've been here the whole time?
Not everyone's as obnoxious as you, AJ. Like,
Oh.
so.
No, I know.
You let him talk to you like that?
He's the best one.
they're weird too because they're like
You're the best.
No, he's a starter.
Starter. Or like,
I like I haven't been one like that.
Okay, so we're gonna go watch
Math by fives.
Oh yes.
Frank.
Oh my god.
Frank.
Mr. Ye. This thing does have a.
yeah, it does. I just don't know how to do it. Okay, so we're gonna look up a woodwork.
Chess. Oh, it's chess.
Dude, that's magic. Well, it has it. Now I don't know how to.
By the way, this is a part of the lesson. This is a part of the lesson. So pay attention. It's
Same thing.
I can't find a video.
Oh, wait.
Hold on a second. Let me.
That's how he worked out.
Hold on. Let me look for it. Give me a second.
Look at that.
Sorry, that's Well, left of the meeting. Well, I'm sorry, come back. Please.
Huh? Japan.
Come back.
Or,
Wood turning the place.
or,
Come back, please.
related to someone who has
What? Mommy's milk.
then I'd be related to someone who was related to
Jacob, stop.
you probably.
Jacob, bro. Well, I'm coming back once.
Okay, so we're gonna watch this video, and this video is very important.
I thought it was golf.
5 million of them.
It's a very interesting. Woodworking is very interesting, and also as much as ceramic is. So yeah, they take a piece of wood here, and they just they try to find the center, and the center is really important. You want to figure out a center. That's we're gonna rotate them. So when we rotate them, we're gonna get something called axis rotation. The axis rotation is very good. So now you can actually just carve in. So now the what it do is you start carving the cylinders, right? It's carving the cylinder. And cylinder basically the axis rotation to the outside edge is exactly the same length. Okay, exact same thing. So that's how you get a cylinder. So now it's a cylinder. Now it's keep on carving more. So now it's cover some like designs in there, and it's pretty cool. So, but the things about it is I'm gonna show you in a second. See if we can go a little bit faster. See, now he's carving insides.
He was really drilling deep.
That's what she said.
Are you not? Dude. Forging wood.
So, if you pay attention to this part, right? You pay attention to this part, you say, hey, look, there was an inner curve, inner radius. Do you see that inner radius there? And there's outer radius. Guys, those of you guys, I don't think it's funny. Either Will or Anthony or anybody like this, it's just not funny. Guys, can you grow up, become more mature? Seriously? That's gonna be probably the most honest thing I can say. So if you see this, I mean, you get to understand a little bit how things work, and you see the hole there. If there was outside radius and inside radius, that's really important for you to see. Now, I'm going to show you here. I'm going to give you two situations here. One is if I think this is a ham, right? A ham is a kind of this size, and you can cut a slice, right? If you can take a ham and you slice it, each slice is going to be look like what?
A circle.
It's a circle. It's the solid circle, or it's the empty circle, or what?
Solid circle.
It's a disc, right? So it's gonna form like a disc. Does that make sense?
Yeah.
So each slice you cut is gonna be a disc. Now, when I get this cup, if I open up, if I cut a slice this way, what's my slice gonna look like?
Empty circle.
Well, it's gonna be looking like a ring, right?
Yeah.
That's what the word.
Like a ring, or matter of fact, it's probably look like washer. A washer is basically disc and washer is two things that we're gonna study today. So besides we study area between the curve, we're gonna study something called disc versus washer. So now you see the inside curve there. It's very, very cool. You see the outside. So you gotta be able to visualize this kind of type of shapes. So you say, okay, well, let's do this. We're gonna start by building some structure for this class. We're gonna say, let's go up building some more important things. So right now we're gonna talk about volumes. Now, volume of not any kind of shape. They can say, if I can find a volume basketball, that's super easy. 4/3 pi r cubed, that's the equation. 4/3 pi r cubed of a sphere. And then you say, yeah, that's easy. That's okay. We can find volume of a cube. That's fine because geometry is s times s times s. And that's fine, and that's fine. But some specific type of shapes, for example, which kind of shape that you cannot find? What kind of sports the balls?
Baseball.
Football.
Baseball is actually is still sphere. Football, right? Football is a really weird shapes, right? In geometry, there is no formula for football. There is a formula for balls, but there is no formula for football. So you say, wait, how do I find the volume of football? So volume of okay, so let's say volume of vase. Have you seen vase before?
Yeah.
You can pull out image of any type of vase. I used to bring vase to school, and I use drills and I do things. But if you just look up vase,
What about the water bottle?
well, like this type of vase, the lobby glass rose vase. So how do I find the volume of vase? And some people it's gonna be very clever. Says I can pour in the water and then take the water out down from a measurement cup. I can measure it that way. Yes, that's true. But can we calculate them? That's the thing. Can we calculate them? It's any way to calculate the shapes of a vase.
I feel like if you found the area, I don't know how you would do this, but if you found like the area of the cutout and then just rotated it around.
Well, that's the idea that we're gonna introduce. Yes.
Couldn't you just like make the area down like the sides and introduce like depth to it? Further radius.
Well, sort of. We're gonna talk about it in a second. Okay, so just let me talk about it. Volume. There was two methods. There was a disc and versus washer. Now there are another one. It's called shell, but we're not going to talk about that one. So there's a shell method, but we are not going to talk about it. But I'm going to tell you that there's something exists that can take care a lot of situation that disc and washer cannot take care. So this is going to be a washer method versus disc method. Okay, so what is the disc? Well, disc, I'm going to give you an equation of formula. So it's going to be r square of x pi between a to b. Does that look familiar?
Yeah.
What is it?
That looks like the circle area for me.
Yeah, pi r squared. It's like r squared. We do an integration on it. Pi, we kind of just leave outside. That's constant. So pi r squared. And then you can be a y perspective as well. A to b of pi of r squared of y. Then you say, oh, okay, well, let's go into a washer. A washer is a little bit different. So remember, this is a pi r squared. This area is equal to pi r squared, and that's the disk, right? Because we have the center, this is the r, and then actually this is the big R, and let's get this. Now, what happened if it's a washer? Well, washer is actually from these shapes of big R square of x minus small r square of x dx between a to b pi. And that's between a to b pi of big R square of y. I pretty much just repeat it because I can do y perspective as well. And then the different perspective offer you different shapes. Another thing is like the x perspective, y perspective. So the way I kind of think about woodworking is always x perspective. Can you think of any other things rotating around y perspective? The class that we offer in the school. Ceramic. Good job. Ceramic is actually vertical axis because that, what's that turning table? Is that what it's called?
The wheel. Pottery wheel.
The wheel?
Wheel.
The wheel turning is facing in the y direction. So the axis rotation is y. Anybody take ceramic class in here? Do you like it?
I love it. I'm ceramics too.
Okay, it's really relaxing. And then some people says, don't take those useless class.
No, take it. It's so hard.
I really think about a lot of times the creativity is come out from those classes. If you think about Steve Jobs, like his most interesting class in college, he didn't go to any class except one class. You know which class he go to?
Ceramic.
Robotic.
No, calligraphy.
Oh, yeah.
And due to calligraphy, he create fonts. On his first Apple computer, he created different fonts. And then Microsoft kind of steal them.
Yeah, Microsoft.
Yeah, so a lot of time is, yeah, you should take those relaxing class. You might not find out that's actually the Steve Jobs kind of get inspiration from calligraphy, become the font, and you say, oh, that's cool. But anyway, so how do I find the area of this shape though?
Using
You rotate it onto its y-axis.
No, we're not talking about that. We're just talking about a simple area of shaded region, and this shaded region is going to be this.
Find the volume of the blue one minus the volume of the red one.
So we're going to build the first R. The first R, we're going to call it big R. So this is a big R, and this is the small r. So how do I find the area of shaded region?
Area of big R minus.
interesting.
By any chance, would this be a top view of the base?
It could be, but it really depends. Probably ceramic, probably, yeah. So in this case, a lot of people thought it's this, but it's wrong. So the wrong perspective is this. The wrong perspective is they say pi r minus r squared, and that's wrong. And I'm going to give you an example why it's wrong. So the correct one is actually this. So this one, they should write it down. It's going to be pi of r squared minus r squared. And some people say they look the same. They're not the same. Because if you distribute that inside, there was a middle term in the middle. So the second one is correct. The first one is wrong.
So then you'd just be doing a small circle.
Yes, you'll get a smaller circle for the second one. You'll get this probably shaded region of the smaller circle than that. It's probably like this big, the area of that, inside the outer rim of the circle. So because you take the two difference, you take the big R, take the minus small r, you're going to get a smaller difference. And then that circle is going to be a smaller circle, not the outside rim. So it's much less. So this is actually much less than this. So those are things that you should have intuitively understand. Now, with that being said, this is the most notes you're going to take. And this is the part that's coming.
Oh, yikes.
Okay. Or you can choose the lesson and just take a picture at the end. But I'll try to have a good handwriting here. So there were 7 steps. Procedure to do this problem. Shh. Those 7 steps is not hard. It's very, very easy. You just have to think about it and think about it goes. Now, the 7th step is gonna be this. So the 7th step to solve volume problem. Okay, so the 7th step to solve a volume. So we're gonna say, hey, let's do this. The first step, draw the graph. Draw the bounded graph. Not only that, you also have to do make sure draw the axis of rotation. Make sure you draw axis of rotation. If you don't draw axis of rotation, that's bad. Make sure you draw this. Axis of rotation. Something very important besides the graph, there's axis of rotation. Second, we are almost there. Second, we're gonna figure out, we're gonna make sure you draw in this order. Has to be in this order, okay? Draw a line or lines, and we're gonna talk about lines from, make sure the order has to be this, from axis of rotation to the boundary. Okay, if you have one boundary, that means a disk. If you have 2 boundary, that means a washer. So one line, if you only see one line, then it's gonna be a disk. If it's 2 lines, usually the maximum you're gonna get is 2 lines, then it's gonna be a washer. Is 1 line, it's gonna be a disk. 2 lines, it's gonna be a washer. But you have to draw from the axis of rotation to the boundary, not the boundary to the axis of rotation. The way you draw has to draw from the axis of rotation to there.
How can you tell where the axis of rotation is?
We'll give it to you. That's the thing. That's a good question. We'll give it to you. Third, decide. So in this case, in this step that you're gonna say, this will decide, this step you would decide that this going washer. So you had to decide is this or washer. You draw one line first. The third step is you're gonna decide dx or dy. So dx usually means perpendicular to x. And dy usually perpendicular to y. To y-axis.
So if it's dy, it's sideways, I guess, like this. Okay.
So we decide a disk or washer. We decide what a dx or dy. The fourth step is decide the boundaries. Decide a boundary. It could be x boundary. It could be y boundary. So if the dx, that means every function need to be in terms of x. So function need to be in terms of x. Function need to be in terms of x. And this gonna be function need to be in terms of y. The fifth step. Don't forget following thing. Don't forget pi. Pi is always outside. Don't forget about the square. Don't forget about parentheses. All those things, and lastly, the boundaries. 7.
Wait, do you have a y and x boundary, or do you have one or the other?
You have either x boundary or y boundary,
But not both.
not both.
What happened to number 6?
Which is I'm gonna talk about in a second. Okay, this one is actually 5. Wait, this one's actually 6. Sorry.
Oh, okay, there we go.
5. Make sure you write down the Rx if you have disk, or Ry for disk, and the Rx and Rx and Ry for washer. So you have to find out the inner radius and outer radius for washer. For disk, it's only one radius. 7, the last step. Function in term of x is distance from x-axis to the curve. The same thing, I'm going to repeat this everything again. So I'm going to copy and I'm going to paste. Function in terms of y is the distance from y-axis to the curve. This is how much you're going to write today. So this 7 step, and we're actually going to start doing them now.
Yeah, real quick, can I use the bathroom?
Sure, you can take a picture of this.
Take a picture of your poop for me.
Will, can you be more mature, seriously?
Yeah, we should all start beating up Will every time he says something.
All right now.
Yes,
Sorry, I want to talk
Your hands hurt?
Yeah. I've written a lot today.
Oh, it's not only my class, right?
Yeah, I have an essay.
Yeah, I know right BBQ.
Yeah, it's all your fault. Today, out of all.
Why is that my fault? EBQ has nothing to do with me.
It's an AP class. You're an AP teacher.
It has nothing to do with me. I teach you how to do math.
Everything to do with you.
All right, sure. I'll take the blame.
That's personal at this point.
Yeah, I know, right? We're gonna follow the 7 steps, and all the 7 steps they are related to each other. So let's start with the football. A lot of time I cannot evaluate football, and I'm gonna show you here. The football is gonna be. I'm gonna give you a question that the shapes almost look like a football. So we're gonna simulate as this. We're gonna say square root x. You guys know square root x graph look like an eyebrow, right? It's only when x is positive. And I'm gonna cut off the eyebrow. I'm gonna say also x-axis. So besides the x-axis could be y equal to 0. So that also means x-axis. Also x equal to 4. And then we're gonna say rotation. We're gonna write down rotating around x-axis. Rotating around x-axis. So we got a situation here. We got 1 here. We're rotating this x-axis. Okay, first of all, I want you to draw this boundary. I draw y equal to 0, x equal to 4, y equal to square root x. Meanwhile, I'm going to figure out how to do something. Did you guys finish drawing?
Will the homework be due tomorrow morning?
No, Friday.
Okay.
It's only first 4 problem after block, and after the block, then we can do together in one period or one of those small periods. So basically, this is y equal to 0, and this is the x equal to 4. Okay, now axis rotation, I'm gonna rotate around here. Make sure you draw this. This is called axis rotation.
Wait, what? How did you draw that? Okay.
Square root x, you should know how to graph that.
No idea how to.
Just right. Like, you know how 9, the root of 9 is 3. Go to 9 and put 3.
So for 4 you put 2.
Yeah. And then for 9 you put 3. And that's the 2 points you got. That's all you needed.
Wait, but yeah, you're right. That's you get 2 2. And then oh, does he have every 2 boxes?
So some of you guys gonna have a little bit hard time to understand this. So each box is 2. Each box is half.
Oh, why
So-
did you do that?
I thought you would figure out by now.
He's probably stupid at it.
He's told you to shut up probably 20 times today.
Okay, so it's between 1 and 4. So now, if you realize, I call this shape, it's called a quarter football shape, or sometimes I call it eyebrow shape. This shape is very popular because it's very similar to football. If you think about this as axis rotation, right? If I take a drill, I used to have drills here, and I do today. So think about if I have this shape as a drill and put that shape right here, right? And I rotate them. What will happen if I rotate them? It's gonna rotate inside and outside. Does that make sense? It's gonna make it like a football, half a football shapes. If I take this and I rotate them, and it's gonna be a half football. Does that make sense?
That makes sense, Mr. Yaden.
You can rotate inside the board and outside the board. It's gonna rotate. Now, if you cannot see it, I'm gonna show you better things here. I'm gonna show you here. So from decimals, they actually have this, and I can let you play around a little bit. So this one is gonna be like this shapes right here. So let me see if I can find it. However, solid revolution. There you go. So you see here. So this is the graph, that square root x graph, right? Now you can rotate them inside and outside the graph due to axis rotation. You see that axis rotation on the corner? That you should see it. Page, you cannot see it because you're online. But if you rotate this graph, you see, you pay attention how I rotate them. Wait, how come they don't moving? So it's gonna rotate. See, if you rotate inside, outside, it's gonna form that football shape. Look like it's kind of like football, kind of like a bullet, actually. Does that make sense? Okay, so then we just had to find a value of that. Now, if you realize that if it's bullet, if I cut a slice of a bullet, or slice of football, I'm gonna see a like bullet's probably better. If I take a slice of bullets like this way, right, vertically, right, I'm gonna see a small disc. And if I add up all the discs, I can form a bullets, right? So basically, is you rotating here, and you're gonna do integral. So integral of this, of dx, that is gonna add up each small ring. The disc can get smaller and smaller and smaller toward to the 0. It's actually the other way around. It's actually getting bigger the other way down, like this. And each rotation is gonna give you something like, let's just say like something like this, right? So that's a rotation if you rotate inside and outside the board. So you're gonna form this shapes right here, and that's kind of like a bullet shape. But each of the slides you're gonna get is a disc. So then you say, okay, let's do this. What we're gonna do is figure out all the things. So the first step, did I draw the graph? Did I draw the axis rotation notation? This is notation very important. This is called axis of rotation. Now what you're gonna do is you're gonna draw from axis rotation. Not here, like not here. You don't want to draw there because there's no boundary there. You want to draw within the bound. If you draw within bound, you're gonna form this one. Now, do you see the second boundary? No, right? There's no more boundary. So in this case, this is a disk. That's why each slice you cut is a disk. So then, once you got this is going to be a dx because it's perpendicular to x. That's a dx. So the function has to be in terms of x. So we actually finish, we go back, we say, did we do this? Yes, we did. Did we draw a line? Yes. And we say it's one line, so it's a what? A disk, right? So at this case, we say that's disk. So that's one step right there. It's a disk. What happened? Dx, because the perpendicular to x-axis. Am I going too fast?
Wait.
So it's a disk and dx. So we are already in step 3 already. Step 4, decide a boundary. Do we have a boundary?
Yeah.
Between what value and what value? Not 1 and 4. 0 to 4. Good. Okay, decide a boundary between this is 1 and 4, and then we had to decide the Rx. So since we know it's a disk, there's only an Rx. The Rx is given by the function. In this case, the function is the distance from here. Look at the 7. Is distance given by this. So that's also known as square root x. So we're going to go back to do step 5. The step 5, it says, don't forget pi. First thing. Second thing is the Rx. So in this case, it's Rx square root x square. Don't forget about parentheses and don't forget about square. And then dx between 0 to 4. And then you're done. If you don't know how to do calculation, you don't know how to do integral, you still can get most of the point. That's the cool part is it. You just have to set up correctly. You have to have a pi. You have to have the integral sign. You have to have a boundary. And you have to have a square. And that's it. So if you evaluate this, you end up to be integration between 0 to 4 pi. And that's x dx. And that's going to be x squared over 2 between 4 to 0 pi. And that's equal to 8 pi. So the volume of this is going to be 8 pi. That's it. The work is not a lot. This page looks like very intimidating. But each small step, I'm just trying to word it as much as I can so you don't get lost.
Just go back down.
So this one we can find this. How about the next one? If a same graph, but it rotates around y-axis, I don't want you to do any work. I just want you to visualize what kind of shape that look like, and you can think of what that shape look like, and then it's rotating around y-axis. You don't have to do math. You just have to tell me what shape would it look like. That's the first thing I want to ask you. So y equal to square root x, x-axis, x equal to 4. This is known as y equal to 0, but it was rotating around y-axis. What would a graph look like? That's a very good body language there.
It's gonna look like an umbrella. It'll look like a donut upside down because of the wind.
Huh?
The sun is gonna
It looked like a donut. Look like a shape.
No.
I don't.
No, like a.
Like
You like motor, like it's gonna look like a table from the future that all goes into one point, and it's like floating. That's what it looks like, Mr. Yang. I can draw it, Mr. Yang. It's gonna look like. It's gonna look like that. Ta-da, that's what it will.
What Anthony says is it's probably the closest thing.
Like, no, it's not gonna look like that. It's gonna look like.
Or is it gonna be?
It's gonna be like, so you know, it'll be like.
Oh wait, I accidentally did the opposite.
Yep, you did the opposite.
So it's gonna be like.
It's gonna be nice.
that, but imagine this 360, so it's gonna be like all the way around.
That's why you said so.
But
Piece of
But
bread.
that like.
yeah, it's not a piece of bread. It was a bun cake.
Like a
Yeah, that's what I'm saying. Bun cake. Like.
It looks very much like a bun cake. For those of you guys don't know what a bun cake, I don't know how to spell them. How to spell them?
B-U-N-T.
Why do they call it bun cake? I used to call for the longest time I called it butt cake.
Okay.
I never had it before.
Yeah, yeah.
Yeah, except the outside edge is
I got
cylinder.
it right this year.
Except the outside edge is cylinder. So except outside edge is cylinder, but so there's no curve inside toward, I would say, toward this part on the top part on the top of the cylinder. It's just gonna be completely cylinder, but inside is gonna be a dip, and the dip is what's gonna be matter here. So let's look at this question. So even though they rotate around different axes, they completely form a completely opposite, more extreme or different type of shape. Okay, so you have to think about what kind of shape will they form when you're rotating. So I think this is the hardest part for students is to visualize what kind of shape am I forming, because I'm rotating that is that one piece. I'm rotating around y-axis. So it's gonna form like a cylinder, but the cylinder has a carved end, the concave end, and that concave end is really hard to imagine. So, but not only that, calculation makes it even harder too. So let's look at this. So we do the same graph. And we draw that same, we don't draw a different axis rotation now. Our axis rotation is right here.
I was fighting demons in there, Mr. A.
Oh, you just missed that whole thing.
You just missed like the most
How
important
many
part.
clocks
Oh,
are
where are
on
you?
that?
Dude, there was literally a line to get to the bathroom.
What?
There were like people lined up.
Do they have
inside.
smoke coming out?
Surprisingly, no.
Okay, so now the axis rotation is on the top. So when you rotate this, it's gonna form like a bun cake. Now, then you say, okay, well, let's follow all the steps. Did I draw my axis rotation? I did, right? On the top. So think about this. This is like a ceramic class, right? You're trying to make a bun cake from ceramic. Okay, so first you're gonna form a cylinder. You put a block of ceramic and then you start forming your cylinder shapes, right? And that's the cylinder that you care about, right? So that is the outer curve. So this is the outer curve. So now I'm gonna draw. Remember, how do I draw it? I draw from the axis rotation, which is here. You don't want to draw here because there's no boundary here. You want to draw here. Do you see that there's a first boundary, but there is a two boundary. Do you see the second boundary?
Yeah.
True, it's a ditch.
It's not a disc.
Washer.
It's a washer. Because if you cut in that slice of perspective, you're gonna get a ring. You're gonna get a washer in terms of that perspective. So you take a bun cake, right? If you cut it like horizontally from the top to the bottom, you're gonna form this ring of cake. And that ring is getting bigger, more area and more area as I'm going down. Does that make sense? So now we have a big R, we have small r. In this case, there is this is a situation, is a disc washer.
Washer.
So we did the first step. Did we draw the axis rotation? Done. The second step, we say there's two lines, so it's a washer. The third step is this dx or dy. It's perpendicular to y. Perpendicular to y, so it's dy. Does that make sense?
Yes.
So that means function has to be in terms of y. So that means you had to do extra step here. You had to say x equal to y squared. Does that make sense?
Yes.
You had to solve for y squared. The fourth step, we figure out washer dy. What's the fourth step we had to figure out?
Boundary.
Boundary. So boundary is from where to where?
Here. No, whoa, no. -4 to +4.
Nope, nope, nope.
-4 to 0.
Nicole, what is it? Say it. Nope.
Is it 2 to 4?
Nope.
Oh wait, it's y. It's y. Oh,
1 to root 4.
One direction.
1 to 2.
Good job, Maria. 0 to 2. See, if you're gonna add a slide and then we're gonna stop at 2 because we're doing perspective in terms of this. So it'll be 0 to 2. So we find a boundary. What's my fifth step?
You have to make sure your R's in terms of X or Y, depending on whether it's disc or washer.
Okay, so that's so this is a washer. So they must have a small r, but in this case dy it must have a ry and ry here. So this is the outer radius. What is my outer radius here?
It's 4.
4 is perfect because in order to do ceramic, I need to do the cylinder first, and then I can carve inside to get a butt cake, whatever. So anyway, so that's gonna be 4. Does that make sense? What is small ry?
Also 4?
It's the x value of the function.
Which is what? No, no. It's constantly changing.
So it would be the y values of the function.
what would be your x value?
It would be y squared.
It would be X squared, or not squared, root X.
Y squared is correct.
I'm a genius, guys.
Why y squared though? It's because from this distance from this point to this point, right? And we say at number 7, it's in terms of y, the function, it will tell you the distance from y-axis to the curve. Did I say that? Look at number 7. Look at number 7. So they say function in terms of y is the distance from y-axis to the curve. So therefore, that is going to be y squared. So now we're going to just build a function. The build function we have to say, don't forget what?
Pi squared, parentheses, and boundary.
The boundary is 0 to 2. And the ry is 4. Don't forget a square minus y squared square dy.
Now do you just integrate it?
And then you just type in the calculator. And they will do the integration for you. That's why your homework is set. Your homework, the hard part is set up because I give you the value. I give you a value like 419 or something like that, or whatever, that I already give it to you. Okay, we're gonna go over one last one here. This one is gonna be this one's gonna be a different shapes. Hold on, I'm gonna answer this one. I don't know who's this. Hello?
Yes, I was looking to speak to the person who's in charge of the electric bill at the residence 8508.
Okay, so last part is I wanted you to calculate this. So I'm gonna draw a new graph and I want you to think about new shapes. Same graph, y equal to square root x, but it's different shapes and different boundary. Pay attention, you gotta draw it. Y equal to square root x. You already know how to draw that one. But this time I'm gonna say y is equal to, x is equal to 0. Last time I says y equal to 0, x equal to 0 this time. And then I'm gonna say next one is gonna be y is equal to 3. Okay, but we're gonna say rotating around x-axis. Around y-axis. Or y-axis and x-axis. So we're gonna figure out rotating y-axis. So first thing, I want to rotate y-axis. First thing is I want you to visualize the shape. This shape, I'm gonna give you a clue. I'm gonna give you a clue. The shape is gonna look like this movie from Leonardo DiCaprio, I think.
The Great Gatsby.
No,
Titanic.
no,
Dangling Thing.
no.
What?
Wait, it's Leonardo?
What movie was he in? You know you're not gonna be there.
This shape is everybody can name the shape.
A star.
No.
Like this.
The glass that he holds.
What'd you say?
Is it the glass that he holds to make the toast?
It could be. I don't know which movie you're talking about. Titanic? No, not a Titanic.
The X
No.
right here. And then
Romeo and
the
Juliet.
Y-axis.
No.
Fuck Juliet.
It could look like a bowl.
No. It's not both.
You should have done that.
Like that.
Hey Siri, what movie was Leonardo DiCaprio in? What movies? Like,
There's like thousands of them.
he's in one movie.
Revenant.
I already have one person have it right so far, so.
Revenant.
Can you give me 5 minutes? Inception. It's Inception. Diamond. It's a diamond. Diamond.
What's that movie
What diamond?
Inception based on what kind of shape?
Inception.
What's the Y equal to 3?
You're right.
It doesn't know my movie, bro. Let's go.
You're so confused? Pay attention how you draw it too. Like, so let's draw it together, right? So if I do this, and I'm gonna do it in terms of 9 because I need to go all the way to 3. So I'm gonna, in terms of small things, I'm gonna draw like this one. It's gonna be like this, and all the way to 9, it's gonna be like right here. So this is how my y equal to square root x graph look like, right? And x equal to 0, so x equal to 0 is a vertical line. And y equal to 3 is going to be based on this.
I was right.
So it's rotating around here. The problem is if you have that shape rotating around here, I happen to have this shape. This shape is going to look like this, right? And I should have a drill. I didn't bring my chopstick because I usually put a chopstick here and I rotate them. So if I rotate them, I'm going to form a span top.
Oh, like from that
Inception.
Inception, yeah.
Why is it
That's what I
only 3?
said.
Wait,
That's not what it looks like though, Mr. Yeah. I think this is like called an inverted parabola. I might be
No,
why is
it's a span top.
No, there's like
why is it
Nope, that's a spin top.
why is it only 3 high?
Because I told you y equal to 3.
Oh, 9. Oh, it's 9 long.
So can you guys figure out what is this situation is going to be?
So it is perpendicular to the y.
Yep.
So everything is part to y. Me.
So write it down, don't shout it. Other people need to think about it.
You're right.
We still have good 19 minutes.
On the test, would we?
You guys did awesome, by the way. I like this class, except some like mishap from
Except
Will
Will.
and
Just say Will.
Anthony.
Just say Will.
Will and
What did I
Anthony.
do?
On
Your
the-
maturity is like 3-year-old.
And
On the test, would we be working this out with our calculator or?
No, you're gonna set up first, and then you can learn how to use calculator.
How do we know it's that shape?
Well, we don't know until you think about it. So that's why it's really important for you guys to visualize the shape. The next question, I'm going to say the same shape rotating around x-axis. So, but you have to get the y-axis correct first before you do rotate around x-axis.
This is just a disc, right? Wait.
I don't know, but you gotta, if you work it out, you can show me. Because I don't want other people thinking about it. I want other people to figure out, not because you can talk out loud, other people start thinking. And when we have 40-minute period, we can all work together to figure out things. So my following question is gonna be rotate around x-axis, but let's get this one first before you rotate. Does anybody still have problem visualize the shape? No, it's okay.
I don't know how like in your head you just think of that shape.
Mr. Gary just has a massive
You can't think
IQ.
of that? Sure.
No. It's a. You did pretty good oiled bun cake, right? So it just kind of think about, because now the problem is, you probably have problem is the boundary region. So the boundary region is this case. The other one is like eyebrow shapes, right? So it's the bottom of this part. So this one is just the top part. Now it's rotating. The same thing is rotating y-axis. It's actually the carve out of the bun shape, bun cake. Does that make sense? If you take a cylinder and you take out this shape, the spin top shape, then you can get a bun cake.
Oh wait, do you just think, oh, you're like, oh, when x equals, or when y equals 3, what does x equal? And then like,
So 3 equals 3.
No, I think about rotations. I still think about rotation. If I worst to worst, I can always draw it. If I draw it, it's gonna be look like something like this,
see, I thought it was gonna
and
look
it's gonna
like,
be like something like this.
I thought it was gonna look like
The boundary is there.
that. I
No.
don't know.
So think about this. If I have like something like this, I'm gonna draw on the bottom here. It's gonna be something like this.
How do I just like, oh, I see that.
Right, rotating around here, it's gonna be like this, right?
Makes no sense.
Does that make sense?
So, right here, would this be my setup?
This is like your top. So you're gonna have some amount
Hold on.
of.
Think about it. No, it's not washing. It's like this.
Oh.
So it's everything above the y.
Up
Yeah, so up to.
Oh, I got it.
So the idea is that right in line, it was right underneath.
I had y.
Oh, by the way.
Right?
You had something.
Oh.
That would have been more like.
Ah. I get what you're saying.
Is it like this?
Yeah. And then from here, like up here, you're gonna have.
Yeah.
Yeah,
That's right.
Why is that? 2, 3, 7.
Yeah, that's right. So now rotate around x-axis.
Rotate around x-axis. Okay.
What?
This is a weird.
The same. That's focus.
So I think you plugged in.
That's the first thing I
Then
did.
what about this one?
Then I just draw a curve right here, and then delete those two lines, right? And then draw a line right here, select it with the
No, they
rotation tool,
can.
drag it,
It's not
and
hard.
rotate it around a little bit.
But wait.
I have.
Yeah.
It's giving me.
Wait, are we doing the integral?
I consider taking the engineering course to get things I have back.
Y squared is squared.
Yeah, it's just.
But why?
It's this. Okay, so that means that.
I bit in that bottom.
So it's just capital R.
Zero. Let's try it.
3 to 6.
3 times 3 times 3 times 3 times 3.
Okay, wait. I think it's like this problem.
Square times 3.
It's gonna be 1. Yeah, 1 square.
Paige, you okay?
It's 80. It's 81 times 3.
Wait, we're taking the integral.
243. No, 81 is.
Oh, I plugged it in. I plugged it in. Oh, yeah, I can't plug it in.
If you want to know what's the right answer, Hans got a right answer, so you can look at his work.
243.5. Let's say I got that.
Okay, rotate around x-axis now if you got it.
My favorite when I see it.
Nope.
Maybe. Yeah.
It's a disc. Check it the heck out, Sim, okay? This might help you probably. If you draw it out, just maybe like shade it a little bit so you know where the area actually is, and then for it to be a washer, there would have to be like from here. Now you get it. Do you get it now, Sim? You get my funny little drawing?
I got it. Wait, then you should squirt it.
Oh,
Yeah, okay, okay, yeah. Wait, when you, to do what, right? Yeah. Oh my god. I have some rocks, so. Wait.
Paige, are you following so far?
me?
Talking to Paige.
Oh.
I'm kind of confused on the
Every time it's a page, I just think he's talking.
What did you say?
I'm kind of confused on drawing the line.
Okay, so join on the last one or this one? I cannot hear you.
Like, how do you know where to draw the lines from there?
Oh, how do you draw the lines? Okay, so. Okay, give me a second. I'll go over to Farah. You got it?
I'm just working on it.
Okay, rotation. If you got it, rotating around x-axis. Now I'm gonna work out rotation around y-axis first. So first of all, I draw axis rotation. The first step, check. Very easy, axis rotation. Second step, draw from the axis rotation to the boundary. So what I draw here. And since there is only one boundary I met, that's a disk or washer. So it's going to be disk, right? So those are the process that you're going to think about all those things. So now this is a dx. Does that make sense? Oh, sorry, dy. My bad. I was lying to you. It's a perpendicular to y, so it's dy. So dy has to be in terms of function of y. So it's going to be, well, this one's going to be x equal to y squared. So it's going to be, you have to think about y squared. And the boundary is going to be between 0 to what? 3, because it stops at 3. The way you calculate this is going to be all the way to here and all the way to 3. And stop at 3. You don't go any further. And then you got to figure out what is big. If it's a disk, and then it's big R. In this case, ry. And ry is given by the function. The function is, well, y squared. Because we already said the function is y squared. Here, this is the f of y. So it's just going to be integration between the 0 to 3 pi y squared dy. So the calculation itself is not hard. The setup is the hardest part. So this is a disk. And now try the next one. It's rotating, same question, but rotating around x-axis.
Just gonna look like a parabola. Gonna look like you took a cylinder. You took a cylinder and pushed the football from right there.
Wow, what a good question. It's a washer.
That's a two-dimensional explanation.
It's a halter.
Shut your butt now.
Yeah, that looks okay.
Okay. Thank you. Wait, is that the second one? Garbage over.
It'd be like that block of wood Mr. Ye showed us earlier, where it was the cylinder, and then he cut a little bit out of it.
Yeah, it's exactly like the working one. It's like the maw of a bullet instead of bullet.
I did it wrong. It's like if you did a Boolean difference between a paraboloid and a cylinder. I can only express how to make these.
81 over 2.
Boolean difference.
Yeah.
Or is it Boolean? Boolean or Boolean?
Today the function could be as easy as y equal to 6. So if you rotate around x-axis, it's going to give a cylinder. But the 6 is still a function. Andrew, that hurts my eye.
That's a polite way of saying stop.
No.
It's not even my eye, it's my eye.
No.
You're gonna ruin the one.
It hurts my fake eye. That's what is worse about it.
Yeah. Can you see under your finger? No.
Bro. Then it would be a real eye.
You literally answered that question. You literally answered the question by asking it.
I don't know if like it connects.
Is it Bluetooth, Mr. Yan?
It has a camera, it records.
That's how you should start recording your lectures. Transduction.
Yeah.
I want to cry sometimes.
We all do when we're around Willie.
Okay, so the next one, I'm going to go ahead and draw it. Hopefully you guys understand what's going on. So it's going to be like something like this. So something like this. Now it's rotating around this. It's like the woodwork shop, like I was trying to tell you that where they try to carve out the inside, right? So that's actually, if you cut a slice, it's going to be a washer. But then you say, okay, well, let's go back and let's say that's rotating around x-axis. So if you're rotating around x-axis, it's going to be looking like this. Now remember, you draw not this way is bad. You draw it from axis rotation. So first line and the second line. So obviously this is a dx because it's perpendicular to x. It's a washer or desk? Washer. What's the boundary between what value to what value? Now this one is tended to be really hard, but just think about 3. And 3 is gonna be all the way to, if it's 3, but you wanted 3 is equal to square root x, right? So you want to square both sides of 9. So it's gonna be 0 to 9. So again, the function is correct, which is square root x, which is fine. This is square root x, that's fine. So the top part, the big R of x is going to be, well, the big R of x is a red one. The red one's a constant. It's always 3. See that red line? It didn't matter where. It's always 3. It did not change. So that's 3. So that's equal to 3. Are we okay here?
Yeah.
Small R of x is going to be the small thing. The small thing is given by the function, which is square root x. So once you did that, so it'll be integration pi, don't forget, 0 to 9, and then 3 square, and square root x squared minus dx. And then you're done.
Yay! I'm so happy.
Sometimes it's about a belief that you can do it instead of just say, I cannot do it. A lot of times just say, you know what, you gotta fake it until you make it. That's the mentality. It's you might not be the best student, but sometimes you just have to pretend that you are. And if you pretend you are, then you're gonna turn out to be okay.
That's inspirational. I hear this.
No, well, you can solve it, but you can use calculator for the homework. So the nice thing is you can plug in the calculator and see if it's working. If it's working, that means you got your setup right. If it's not working, that means your setup is wrong. Then you gotta restart.
Wait, is it 72 pi? That's what I got. I don't know if that's right.
I don't know. Hung got it. I don't know.
I got 81. It's 81 over 2 pi. Yeah.
Damn it.
Wait, Mr. Gay, for your upper balance, how do you get?
Because you want them to be equal to 3, right? So you're gonna set 3 equal to square root x.
Oh, and then you just solve for it.
Yeah.
You just, okay.
Yeah, yeah, no, it's not that bad. Like, I didn't really, it's hard to like.
It's hard to visualize that shapes too. It's like very hard for people to think about what kind of rotation it's going to be.
I think about it.
Marion, how many brain cells you have left?
I never got to. I think I'm good. But then
Homework, we decided to be able to finish first 4 problem. We're gonna do rest together in class, but the first 4 problem, it should be able to get to it, no problem.
You're right,
She'll probably take me there.
Paige, you okay?
Me? Oh. Well,
I started